Hi guys, I'm back with another Code with Me video, this time solving the problem of is a number prime and using JavaScript to do it. So I haven't looked at it, as always, I haven't looked at this problem before, so I will be coding it for the first time during this video. So the problem is define a function that takes one integer argument and returns logical value true or false depending on if the integer is a prime. Per Wikipedia, a prime number is a natural number greater than 1 that has no positive divisors other than 1 in itself. Requirements, you can assume you will be given an integer. You cannot assume that the integer will only be positive. You may be given negative numbers as well. And then no performance. There are no fancy optimizations required, but still the most trivial solutions might time out. Numbers go up to 231 or similar depending on language version. Looping all the way up to n or n minus 2 will be too slow. Okay, so we could be dealing with some pretty large numbers, and we need to figure out if the number coming in is prime or not. So 1 is not prime. I did not know that. 2 is prime, and -1 is false. Okay, let's go ahead and get started. So I want to find out if a number is prime. Let's see. First step. Well, I know we can obviously use not obviously, but there is an operator called the modulus, which will tell you the remainder of a number. And then, like if we did 2 mod, I think that's how you said, and what is the syntax for the modulus? Let me look it up. JavaScript modulus operator. Okay, so that's the syntax. 12, remainder 5. So 5 goes into 12 2 times, and then you get a remainder of 2. So this operator, this modulus operator, will give you the remainder. So you get a 0 remainder when something goes cleanly into the other. So the number that is going into the other number, that's the syntax. It's hard to remember that. Okay, back to this. So I think I'll be using that operator at some point, but first, let's see. I don't want my program to time out, but I do want to try something. So first, let's figure out these test cases. So we know if num is less than or equal to 0, we can just go ahead and return false. I'll write it all the way out. Return false. Okay. So that's out of the way. Well, actually, it is less than or equal to 1. Because 1 is also not prime. Okay. So now, we need to know if it's divisible by any number other than itself in 1. So one thing I'm thinking of is for num, we'll always be checking the remainder of numbers smaller than num. But we can't loop all the way up to n or n2. That will be too slow. Well, I'm going to loop all the way up to n just to see if it'll open up some thought processes on how to think of something that doesn't loop all the way up to num. So let's see. Um. So yeah, for we'll do let I equals to so for I, and I'll explain this later. That's the num I plus plus. So I'm starting with 2 because 1 doesn't count, and I'm not including num itself because num doesn't count. We want to see if it's ever divisible by something other than 1 or itself. So then I'm going to use this percent modulus num remainder I. Is it ever, and this is going to be an if statement. So if num remainder I is ever equal to 0, we want to return false. Okay. Okay. So it's right now it's either going to return false or it's going to return nothing. So I think I'll actually make a variable. Well, when will this be true? So if number is never divisible by 0, it will never return false, but it's also not going to return true. I feel like there's something very simple staring straight at me. Let's see. I want to force this to return true when it's actually a prime number. Okay, so okay. Yeah, I'm just going to set a new variable called let is prime num, and then I'm going to equals true. And then otherwise, the answer is prime num is going to equal to false. It's strictly necessary. Okay. And then we're going to return is prime num, which will be true unless it's false. Let's see where that gets us. Okay, so everything passed. Then let's attempt everything. Ooh, see, look, it slowed down considerably. Yikes. Exit code, timed out. Okay. All right, so we know this solution, this logic works, but it's not really optimized. Why is that? Because of this loop. Okay, so is there another way for me to check the primeness of a number if without doing a for loop? Okay, so So a prime number is a natural number greater than 1 that has no positive divisors other than 1 in itself. I wonder if is it known what the largest prime number is, and then maybe we can make that the cap. Don't know if that's cheating, but I'm going to Google it. Largest prime number. Oh, okay, that's pretty large. Okay, I don't think that's going to help us much. Okay, so we know prime numbers can get very large. We know that we can pass very large numbers to this function. So a for loop is not advisable. I'm just thinking. I wonder, I hope it's not something that depends on knowing more about prime numbers. Because other than the fact that they need to be greater than 1 and not divided by anything other than themselves. So this is the heart of it. Okay. Maybe we can break this for loop. Like once is prime returns as false, there's no need to loop all the way up. Maybe that'll help. Let's see. Can you break? Okay. Okay. I don't often break for loops, so that might be another thing I need to Google. Bullet timeout. Okay, so that didn't work. Let's bring back what it was previously. Would a case statement be faster? I don't know. I'm completely stumped on this one. Let's see. I have no idea. I'm just gonna look at the discussion. Nope, this thing froze again. Okay. So someone else had the timeout issue. Yeah, specifically designed for the most performant code. Oh, someone's using factorials. See, I don't know what factorials have to do with prime numbers. I don't know if this is a good one. I like ones that only depend on code knowledge. I don't know. I say boo to this kata, and I'll try a different one another day. Thanks.